divide fractions, division of fractions. Just so you guys know, it's from another problem I was doing. Just so you guys know, I don't divide fractions. I actually multiply them. I make the division into a multiplication. I do that because I like to have continuity. I like it to be the same as multiplication because I'm pretty good at multiplication of fractions. So I might as well make the division a multiplication of fractions, and then it's all the same. I'm not doing two complete different procedures, right? It's just one little thing, and then it's all one little change, and it's all multiplication. Okay? So let's go ahead and do this. All right. So I have here, our example is 2/3 divided by 1/2. First thing I'm going to do is I'm going to write the first fraction down again. I'm just going to bring it down. I'm not going to change the first fraction. Okay, that never changes. The second one, however, I am going to change, and that will always change, at least the way I do it. Okay, so what I'm going to do is, it's called taking the inverse, okay? So the inverse is basically flipping it over. So instead of it saying 1/2, it's going to say 2/1. All right? So there it is. I took the inverse. In my classes, we say we're going to flip the tortilla. That's all it is. All right, so we flip the tortilla. Funny thing happens when you flip it over, though. The division turns into a multiplication. Ta-da! That's it. It's really not that hard to turn a division of fractions into a multiplication of fractions. And don't worry, the answer will be right every single time. So I look to see if I can cancel, and that's another nice benefit about multiplication. You have the opportunity to cancel. But in this example, we can't. So we just go ahead and do the multiplication. 2 times 2 is 4. And 3 times 1 is 3. Right? So I have 4/3. And I need to ask myself, is 4/3 proper? No, it's not. Remember that for it to be proper, the numerator needs to be smaller than the denominator. So that's why this is improper, because the numerator is larger. So how do we change that? How do we fix that? We just divide it. This actually says 4 divided by 3, but you probably want to visualize it like, well, how many times does the bottom number go into the top number? And so it goes into it, it goes into it one whole time, right? 3 goes into 4 one time. What's left over? What's the remainder? The remainder is 1. And my denominator is not going to change, all right? So I just bring the 3, I just put the 3 back down there, and it's good. Okay, so now my fraction is 1/3. This is a mixed number. I have 1 and 1/3, but I'm still looking at my fraction. 1/3 is now proper, because 1 is smaller than 3, right? The top one's smaller than the bottom one. And is 1/3 in its lowest terms? Yes, it's in its lowest terms. It can't be reduced anymore. So there we go. That mixed number would be our final answer for the division of 2/3 divided by 1/2. Okay? But we're going to do a couple more, so just hang on. Let's get a little bit more practice here. And I'll erase my little check marks here. Okay. So let's make this one 1 2/3. We'll make this one 5/8. Okay. So 1 2/3 divided by 5/8. You know, I don't know if I said this in the multiplication video, so I better say it now. There's a little rule here that we need to keep in mind every single time that that we're multiplying and dividing fractions. Okay. So here it goes. When we multiply and when we divide fractions. Now, let me say that again. Better. If we're multiplying 2 amounts, or if we're dividing 2 amounts, and if just one of those amounts has a fraction, everything in that problem needs to be in fraction form. Or that is to say, I can't have any whole numbers. Okay, so here we go. I'll help. Let's see that work here. I have 2 amounts. I have 1 2/3 and I have 5/8. Do I have a fraction in one of these? Yeah, I got 2 fractions actually. So that means that I can't have any whole numbers. I got to do something with this 1. I can't have the 1 there. Okay, that's what that rule is. Okay, multiplication, multiplying and dividing fractions. You can't have whole numbers. Okay, So we have to do the conversion here. We have to convert 1 2/3, this mixed number, into an improper fraction to be able to do the operation. Okay, so first things first, let's convert this mixed number into an improper fraction. And remember that it's starting with the denominator, multiplying by the whole number, adding the numerator. So 3 times 1 is 3, plus 2 is 5. And the denominator won't change. It'll stay 5/3, okay? That's it. So we've incorporated the 1 into an improper fraction. Okay. So divided by 5/8. Now, I'm going to go ahead and take the inverse or flip my tortilla, right? I'm going to flip it over. And remember that when you flip it, so instead of 5/8, it's 8/5. When you flip it, the operation changes from a division to a multiplication, or its opposite, okay? So here we go. We have it ready to do the multiplication. The multiplication. Again, remember, in multiplication, we have an opportunity to cancel. And in this example, we can cancel. Remember that canceling works. It has to be a numerator on top, a number from the top, and a number from the bottom. They can be from the same fraction, but they don't need to be. They can be from different fractions. And if the one on the top and the one on the bottom can be reduced or divided by the same number, or the factor as it's called, we should do that, okay? Because it makes our number smaller, makes it get closer to the final answer a little bit quicker, I think. So here we go. So 5 and 5, I have a numerator and a denominator, one from the top, one from the bottom, that can both be divided by the same factor, by the same number. So that will be 5, they can both be divided by 5, right? So 5 divided by 5 is 1, and again over here 1, okay? Just dividing, just reducing them, that's all I'm doing. Now I'm going to do my multiplication with these numbers. The 1 times 8 is 8, and 3 times 1 is 3. I'll go and write my answer down here, 8/3, because it's my answer. It's my last answer, but it's not. Remember, I always got to check these two things, right? I got to make sure it's proper, and I got to make sure that the fraction is in its lowest terms. Okay, so 8/3, proper or improper? It's improper, right? Because the numerator is larger than the denominator. So let's go ahead and fix that. Go ahead and use black. So again, I like to say, how many times does 3 go into 8? Goes into it 2 times, right? My denominator is not going to change, so I'll just go ahead and put that there right away. All right, so we said 3 goes into 8 2 times. What's the remainder? 2, right? All right, there we go. 2 2/3. 8/3 is equal to 2 2/3. And if you don't believe me, you can do this operation again just to make sure. 3 times 2, 6, plus 2 is 8 over the same denominator. So we're good. Now, okay, now the fraction is proper, so I can go ahead and put my little check mark there. But is my 2/3 in its lowest terms? And yeah, it is. This one is. Just because it was improper and you made it into a mixed number, doesn't mean that you're done with this part. You always got to make sure that the fraction is in its lowest terms. Okay, because sometimes you'll get a fraction where it's improper, you convert it to a mixed number, and the fraction is still not in its lowest terms. But being that we canceled, before we did the multiplication, we did this little cancellation with the 5s, that pretty much guarantees that the fraction will be in its lowest terms, okay? If you didn't do the canceling, and you just multiplied, you would have had to reduce 2/3. It would have been a bigger number, I'm not sure. Okay? Let's do one more example. At least one more. Okay. All right. We'll go ahead and use the same 1 2/3. But now I'm going to put divided by 2. All right? In fact, let me just get this down right here right away, because we already know that it's 5/3. Okay? How do we do it when there's just a whole number like 2 or 10 or 5 or whatever, right? How do we do it when it's just a whole number? Well, basically, let me change that a little bit. Let me make it a little bit smaller. When you're dividing, okay, so let's go back to the rule. Two amounts, 1 2/3 divided by 2. If I have at least one fraction in that division, and I do, everything needs to be in a fraction form. We already got this mixed number here in 5/3. Boom, check mark, that's a fraction. but 2 is still a whole number. How do I change 2 or any whole number into a fraction? It's really easy. Just put it on top of 1, okay? Put a 1 underneath it. Because what this says is 2 divided by 1. 2 divided by 1 is 2. So you're not changing anything. I'm just changing the way it looks. That's all I'm doing. But now it looks like a fraction because it is a fraction. Now I'm going to do the inverse. I'm going to go ahead and flip my tortilla because I don't want to divide. I want to actually multiply. So to get it to multiplication, I flip it over. Okay. Oops. In my fraction bar. There we go. And I look to see if I can cancel number on top with 1 on the bottom. No, there's nothing I can cancel here. So we go ahead and do the multiplication. And that will give us 5/6. It's hard to say, 5/6. Okay. Is the 5/6, is it proper? Yes, it is proper because 5 is smaller than 6. So, well, we already got to check. Is it in its lowest terms? Yeah, it is in its lowest terms. They can't be reduced by the same number. The 5 and the 6 can't be divided by the same number. So, that's it. Lowest terms. Okay? So let me just talk about a small little phenomenon here that is kind of interesting, I think. Fractions that have a 1 on top, like 1/2, 1/3, 1/4, 1/5, etc., right? ... They're kind of interesting. Because remember, if you flip them over, they turn into a whole number, right? So for example, if I take 1/2 and I flip it over, I get 2/1. What is that? That's 2 divided by 1. What's 2 divided by 1? That's 2. Okay? If I take 1/4 and I flip it over, I get, can you see this? Yeah, you can see that. I get 4 divided by 1. That's 4. Okay? So let me put an example here. Show you what I'm trying to talk to you about here, what I'm trying to explain. It's a little funny. It's a little strange, I think, for some people. So we'll put 12 times 1/2. Let's make it easy. Right? This might not seem very familiar to us, right? We don't see this all the time. You might be starting to do this, right? Well, it's a whole number. I need to put a 1 underneath it. And I see if I can cancel. Yes, you can cancel the 12 and the 2. Do the multiplication. Check if it's proper. That will work. No problem at all. That will work perfectly. However, take away this little 1. All right. What happens if I take the inverse? I know it's multiplication, but if I flip it, it'll turn into a division, right? Remember, flipping the second fraction or the second number just changes this. So you can change it from multiplication to a division or a division to a multiplication, back and forth all day long. So let's just see what happens here. Remember that 2/1 is what? It's 2. Anything over 1 is just that whole number. That's all it is. But my multiplication changes to a division. This, you probably can't see those. Here we go. Changes to a division. So 12 divided by 2, 1, 2, 3. It's 6, right? I mean, it doesn't take that much. This is super duper familiar to us, I would hope, right? I mean, 12 divided by 2, I think everybody can rattle that off. These students see this 12 times 1/2, and they start freaking out. They're like, I gotta do work, I gotta write it down, I gotta do all this stuff. Really, you don't have to. So what I'm trying to let you know, all these fractions that have a 1 on top, 1/3, 1/4, 1/5, etc. If you flip it over, it's just that number. It's just this is really just 2 if you flip it over. 1/3 is really 3 if you flip it over. 1/5 is just really 5 if you flip it over. So let's put an easy one here. Let's put another one really quick. I don't know. Let's see. 24, maybe. 1, 2, go. What's the answer? It should be quick. This is what I mean. It saves time if you recognize this as, right? It equals 6. It's 6. Okay. Another one. 48 48 times 1/8 is the same thing as 48 divided by 8. Just flipping it over. Remember, it's 8 over 1, but over 1 is just 8. Okay? So play with that, play around with that a little bit. Maybe on an exam or something, it might save you a little bit of time if you recognize this as 48 divided by 8. Okay? It's an eighth of 48. It's one piece. It's an eighth of 48. I don't know how else to say it. Okay, well, good luck. Play around with that. See what you get. I would say put it over 1, do the whole operation like I showed you, and then start looking at those connections. Oh, it was really just 48 divided by 8. It gave me 6. All that work for 6. If you see this is a lot easier to understand, I think. And it's just a matter of getting this kind of familiarity with this to come over to this world too. If we can get familiar with this the same way, it gets a lot easier for us. Okay, well, give it a shot, see what you get.